Here is another example. AJ is entering the final stretch of a cross-country race, and he is behind the leader by 15 meters. AJ is running at 8 meters per second, and the leader is running at 8.5 meters per second. AJ turns on the jets and speeds up at a rate of 0.2 meters per second squared until the finish line. The leader is tired, and so he slows down at a rate of 0.1 meter per second squared. If AJ catches him just as he crosses the finish line, how far does AJ have left in the race when he starts speeding up? So let's draw out this diagram. We have AJ, who's running, and then runs faster, while the leader is running fast and then starts running slower. Let's list what we know. And I'm going to be using my subscripts here. We know that delta x for AJ, I'm just going to call that delta XA, is equal to 15 meters plus delta x for the leader. So we know that he has 15 more meters to run than the leader does because he's behind him. We know that the V initial for AJ is 8 meters per second, and the V initial for the leader is 8.5 meters per second. AJ's acceleration is a positive 0.2 meter per second squared because he's getting faster in the positive direction, and the acceleration for the leader is negative 0.1 meter per second squared because he's getting slower in the positive. And we are trying to find how far AJ has left in the race when he starts speeding up. So we're looking for delta x of AJ. Based on what we're given acceleration for each of them, we're given V initial for each of them, and we know how far apart they are in the beginning. One thing that we don't know is time, or V final. So it's up to us how we want to go about solving this in terms of what I have and what I can eliminate. The equation that it makes most sense for me to use is delta x equals 1/2 a t squared plus V initial t. We don't know delta x and we don't know time, but we do know that the time for AJ is equal to the time for the leader. So they're going to end up at the finish line at the same time. We just don't know what that time is. What we do know from the given is delta x for AJ in terms of delta x for the leader. So we were given that delta x for AJ is 15 meters more than delta x for the leader. So let's look at this equation for the leader. Delta x for the leader is equal to 1/2 times the leader's acceleration, t squared, no subscript with the t because the t's are the same for the leader and AJ, plus the leader's initial velocity times time. We know that delta x for AJ, let's do that in another color. Delta x for AJ is equal to 1/2 of AJ's acceleration, t squared, plus AJ's initial velocity times t. Right here, we have delta XA in terms of delta XL. So I'm going to make this substitution. 15 meters plus delta XL equals 1/2 a t squared plus V initial a t. and then bringing the 15 over to the other side, delta XL equals 1/2 A T squared plus V initial A T minus 15 meters. This gives me two equations with two unknowns. So I don't know my delta XL, I don't know my T's. However, two equations, two unknowns, I just set them equal to each other since they've already got the XL isolated. So we are setting 1/2 A L T squared plus V initial L T equal to 1/2 A, there should be an A here, A T squared plus V initial A T minus 15 meters. The only unknown in this entire equation is T. So let's get everything over to one side. Isolating the T's isn't going to help much of anything. This is going to end up being a quadratic. I can't cancel T out anywhere. So let's get everything over to one side and set it equal to 0. So 1/2 A L T squared minus 1/2 A T squared plus V initial L T minus V initial A T plus 15 meters equals 0. Okay. And now let's factor out what's in common. So T squared times 1/2 A L minus 1/2 A plus T V L, oops, that's an L, minus VA plus 15 meters equals 0. T squared times 1/2 of negative 0.1 meter per second squared minus 1/2 of 0.2 meters per second squared plus T times 8.5 meters per second minus 8 meters per second plus 15 meters equals 0. So these coefficients, it would be negative 0.15 meters per second squared T squared plus 0.5 meters per second T plus 15 meters equaling 0. The coefficients for the quadratic formula, this is your A, this is your B, this is your C. Plugging that into your calculator, we get, and I'll do this right now, so negative 0.15, 0.5, and 15. A negative 8.47, you know time can't be negative, so that answer is wrong. And a positive 11.804 keeps on going seconds. So the time for the whole race is 11.804, keeps on going. We're looking for the total distance covered by AJ. So since we have time, we can now go back to the equation. Delta X equals 1/2 A T squared plus V initial T. We know A, we know T, we know V initial. So this equals 1/2 times AJ's acceleration, 0.2 meter per second squared, times the unrounded number. And again, the only downside of the quadratic formula program is you can't store the number unless you have one of the newer calculators. So you do want to type in the whole 11.0460422 in your calculator, squared, plus his V initial, 8 meters per second, times 11.80, keeps on going, seconds. Putting all of this into your calculator, you should get 108.37, keeps on going, meters. Only one sig fig, so delta X for AJ with one sig fig is approximately 100 meters. You could have done this problem using the no time equation. It would have been really messy with the squares and factoring, but it is possible. This you could also consider messy since it was quadratic, but completely solvable. It just took a little bit of thinking as to what we had to do. So this problem is fair game, as is every other difficult problem for a test. So make sure you're understanding the process. It might not look like there was as much substitution, but you still had 2 equations, 2 unknowns. So our old problems had 4 to 5 equations, 4 to 5 unknowns. But again, same process. Think about what you don't need, think about what you can eliminate, and then get rid of those to solve for what you actually do need. 1/2 AL was negative 0.1 meter per second squared t squared minus 1/2 of 0.2 meters per second squared t squared plus 8.5 meters per second t minus 8 meters per second t plus 15 meters equals 0.